When we think about aging or chronic sickness, we usually imagine it as the slow, inevitable passage of time. But if you zoom in close enough, you don't see time passing. You see a robbery in progress. Healthy cellular structures are constantly being destabilized and violently stripped of their essential parts. The culprits here are reactive oxygen species, commonly known as free radicals. Put simply, these are damaged, unstable molecules with a critical piece missing, an electron. Because they are unbalanced, free radicals are highly volatile. To stabilize themselves, they will attack a neighboring healthy cell, find an electron, and aggressively rip it away. This doesn't actually solve the problem. The cell that just got robbed is now missing an electron, meaning it became a brand new free radical itself. It immediately attacks the next healthy cell, triggering a destructive cascading chain reaction that biologists call oxidative stress. Your body has natural defenses to stop this molecular theft, but modern life constantly overwhelms them. Poor diets, ambient pollution, and chronic stress force our bodies to produce free radicals at a rate far faster than we can naturally handle. As the chain reaction accelerates, the damage spreads. On a cellular level, it begins mutating DNA. On a systemic level, it triggers widespread chronic inflammation throughout the body. This live blood analysis of a 65-year-old man shows physical evidence of cellular damage. Instead of a healthy, flowing environment, the internal terrain is congested. Red blood cells have clumped into tight formations, while white threads in the plasma indicate blood coagulation is activated. When the cells are jammed together like this, they cannot move freely through the smallest capillaries. We are looking at a system where systemic inflammation has created a biological terrain that can no longer properly circulate or sustain health. To stop a microscopic feast that is desperately seeking an electron, you need a specific countermeasure. You need an entity that already has surplus electrons and is entirely willing to give them away. In chemistry, that is an antioxidant. Because it is difficult to extract enough antioxidants from food alone to halt severe cellular damage, researchers developed a targeted technological intervention to boost our free radical scavenging capabilities, a water ionizer. This device artificially alters the physical properties of ordinary tap water. Inside the machine, the filtered tap water undergoes a process called partial electrolysis. By passing the liquid over electrically charged titanium and platinum plates, the device separates the water into an oxidized acidic pathway and a reduced alkaline pathway. The water traveling down the alkaline pathway undergoes a crucial shift, gaining a high negative ORP. The electrical charge packs the water with a massive surplus of free electrons. This electrical modification upgrades standard tap water into a highly charged delivery system, carrying the exact molecular pieces our damaged cells are missing. The DC electric field over the plates also creates a structural change. It disrupts the hydrogen bonds that hold water molecules together, breaking standard groupings of 15 to 20 molecules down into microclusters of just 5 to 6. These smaller clusters reduce the liquid's surface tension. This allows the water to pass through cellular channels more easily, delivering hydration directly into the cells. Once inside the system, this negatively charged water acts as the ultimate donor. When it encounters the rampaging free radicals, it freely surrenders its surplus electrons. Here is the crucial chemical safety mechanism. The water satisfies the free radical's missing charge without becoming unstable itself. By saturating the system with available electrons, the water provides the exact donor required to neutralize free radicals and terminate the chain reaction of oxidative stress. To see how this microscopic electrical exchange impacts actual human biology, we can examine live blood analysis documented in clinical research by scientist Beverly Rubik. Let's revisit the baseline image of the 65-year-old male subject. This was the picture of systemic inflammation, sticky, clumped red blood cells that had lost their ability to circulate freely. For the next 6 months, researchers introduced a single intervention. The subject drank 1 to 1.5 liters of electrolyzed reduced water every day. He made absolutely no other changes to his diet, exercise, or lifestyle. Now, look at this follow-up image taken from the exact same man after 6 months. The red blood cells have returned to a healthy state of separation. The stickiness and clumping factors are no longer present, leaving the cells as single, free-flowing circles. Because the cells are separated, they move independently. Single red blood cells can easily flow through the body's smallest capillaries, effectively restoring the subject's peripheral circulation. Water is not a passive solvent. It is an active participant in the body's internal chemistry. By artificially altering its electrical potential, we can provide the body with the specific molecular tools it needs to disarm oxidative stress and restore a clean, flowing biological terrain.